I see her going.
Hi, Rob. Good morning, everyone. And we're just testing out one of the slide decks, but I'll be here to bully people into coming to the podium to talk so that you can hear them.
Okay, great. Thank you for helping in room.
Of course.
You can see my slides in the room, okay?
Yeah, they look perfect.
Okay.
What's the rough number of people there?
Hold on,
Sorry.
let me count. Do you want me to include the people helping or the people just
No,
attending?
I really meant for the meeting as a whole, although I'm also curious.
Okay. I think over 200 registered in person and then
Okay.
500 online. The sessions are on 3 different floors, and so, especially, people stop between sessions, get a coffee, so we'll get people trickling in for the next 10 minutes. But I would say let's give it at least another 5. Yeah.
Okay, sounds good. Sounds good. And I have the typical work from home agenda in that I have to wrap up pretty much right at the end of the meeting so I can put my daughter to bed before she gets
Actually, yeah, that's great because I think they've been asking us to try and end even 5 minutes early so that people can get to the next session on time. So we will make sure that you get your bedtime stories in with your daughter. Those are precious years.
Yeah, thank you.
My kids, well, I guess my youngest will let me, my 2 oldest, I can't even come in the room if they're about to go to sleep. Do you want a hug? No. But I guess that's what happens in your 20s.
Yeah,
It's
I'm
normal.
not looking forward to that age. If I could keep at this age forever, I think I probably would.
There's pros and cons to everything, but yeah, that was a pretty good age. I mean, now when they get older, they can do things like go get dinner and bring it to you. So that's also pretty nice.
So Christine, we asked how many people were in the conference. How many people are in the room?
So counting the people that are assisting with the session 4, only 2
Mm.
participants, but very high quality participants. So
Oh, that's more important.
So I had a session on Tuesday, and it was at the same time slot, 9:30 local KST. And we started, I think, with only 2 participants besides the facilitators, and it was full about half hour in. So it's, if our timing is tight, we could get started.
So I think that the issue with not getting started, so the more we squeeze, the less discussion we'll have, and I don't want to without discussion. But I also don't want the people who come in to not join in the discussion because they haven't seen the introductions and got the context for the conversation.
I think it's okay. Do we have a shared document where we can post links to slides for the people that come in late? I can try and get that going while you're giving your talk, Rob.
Yeah, so I haven't created a shared document, and I don't know if there's one generally created for each session.
I don't think so.
I think there's
Hillary,
one because
oh, is there one?
on the
There has been one for most of the sessions I've been in. Okay.
it's on the RDA website.
Okay. I was just doing mine ad hoc, but I guess because I had a SciDataCon session, I was just copying what I'd seen in the RDAs. All right, so we do have some more people joining us. Rob, whenever you want, you can get started. I'm going to sit right next to the podium, so don't worry if any of you don't see, you see no one standing here. I am literally right by it. So if you need anything, I'll jump up and talk.
Sure, and I'll go ahead and give about 2 more minutes to get more people in and let the people who are just coming in get settled, and then we'll kick things off.
Okay, awesome. And thanks, Jan, for posting the link in the chat. So those of us here locally, you don't have to log into Whova. You can if you want. I think we're going to have more remote participants than in person, but there is a shared share doc now where we'll post links to slides and other things.
Okay, why don't we go ahead and get started for the interest of time and to help both myself, who has a bedtime, but also I know those starting in Europe, it's very, very late. Jan particularly said it's 2:30 a.m. So we'll go ahead and kick off and
I
get
don't
things
know.
started.
Some Europeans are party animals. Maybe that's like that's you're on your third bar or something by 2:30. Yeah, no, that's late to me. Okay, Rob, I'll take it away. Welcome to everyone here in Seoul.
Yes. Thanks everybody for joining. And just to put a little background to the conversation and the idea that led to this Birds of a Feather. When we were working with FAIR in the digital object community, the FAIR digital object community, one of the things that kept getting thrown around is that FAIR also meant fully AI ready. So you could basically use that acronym, and if you were fair and met the FAIR principles, that also basically equated to fully AI ready. Now, I was a little unsure that that was the case, though it's a great way to move a product is to call it FAIR, or to push forward a concept to call it FAIR. I wanted to take a little more in-depth and a little more rigorous look at whether meeting the FAIR principles of data sharing was equated in any way to being fully AI ready or AI ready at any level. So the plenaries are a good time to kind of take a step back and think about things from I guess I have to reload my slideshow. Maybe. Now, let me share again from here. And so I kind of delved into this over the last few months and trying to decide and look at what it really meant to be AI ready, and how you could potentially format both data, but also the models, the applications to be ready to be used in a FAIR environment. I want to go view slideshow.
Okay, oh, perfect. I was just going to say, try reloading.
Yeah.
Or show anyway, maybe. There you go. Looks good.
Okay. I may have to do that. I am missing, I think, an image here, but that's okay. So when I sat down to look at what it took to grab a open AI or machine learning application from a repository, or at least a linking of various different AI algorithms, I found out that a novice or a semi-professional IT, if they decide that they want to embrace a new AI technology, it's not as simple as having a data set and pushing it into a application and getting the results. So when you find an AI algorithm that you want to explore, you usually find this in a GitHub repository. The documentation is somewhat dreadful. And sometimes there's a paper to read that describes a little more in depth. And hopefully they also say what the data requirements are and the package dependencies are to do this. So if you gather these things together, then you have to find the right processor type, depending on the algorithm, the correct versions of that, of the compilers for that hardware type. And then you have the model building, which then, if you have a pre-trained model, you then have to format the data to be used in that model. If you are not finding a pre-trained model, you have to find a legitimate training set or create a training set from splitting your data and moving forward, and then execute an analysis. And that's, if you were coming in as a novice or even a IT professional who hadn't used AI before, this takes quite some time. And even me, having been a 20-year IT person and pretty proficient in a lot of the back-end technology, it still took me a lot of both data wrangling and hardware wrangling before I was able to even execute what are some of the state-of-the-art algorithms. So what it should look like in a fair environment, I think, is that a novice user identifies the algorithm they want to explore. They have an identifier for that algorithm or model. They have an identifier for an appropriate training set. They bring in a training set either by registering it with an identifier and the proper metadata, and then they basically input the PIDs for the model, the data they want to use to train, the data they want to analyze, and set some parameters and can move forward to the execution step. Now, this is kind of a end goal to making AI somewhat user-friendly, and to have a researcher who is not familiar with the computing aspects being able to fully utilize the model. So I just wanted to set that back as to where we are today, if you were to grab something, and where I think we need to be to at least have some amount of usability within a general AI realm. So we're going to have 3 talks today. First, Dan is going to talk about what the FAIR for Machine Learning group is already doing. They've been active for a few years now and are doing some great work. Dan's going to describe what they've been doing. Then we're going to have Christine talk about the FAIR Digital Object group and where FAIR Digital Objects are. I will then complete this presentation with my findings from basically, as I said, going from, hey, this is a really interesting thing, I'm going to sit down and try to get some realistic results and the problems that I ran into. And then we'll have some discussion, and Jan's going to help us moderate that discussion and talk about several things in the various realm of making AI fair and where that gets us and what the end goal really looks like, and then some paths forward for proceeding in this FAIR for AI environment and how we can proceed in RDA. So with that being said, I will stop sharing my screen because I don't have Dan's slides. And Dan, if you want to go ahead and start when you're ready.
Okay, so hopefully this looks all right. Yep. Okay. Yeah. So thanks, Rob. Yeah, I'm going to talk about some work that Fdos and I have been leading. As Rob said, it's been a little bit. We've been, I guess I'd say we've been working a little bit slowly and trying to build up community. And I think we're at a point now where we're going to really be ready to move forward. And so I want to talk about where that point is and how you can join in if you're interested, and how you can help us build a bigger community as well. So yeah, so we're going to talk about FAIR for machine learning. I'm putting in this FAIR statement for completeness, but I'm not really going to talk about it other than saying the intent of the FAIR principles was to ensure that data are shared in a way that enables and enhances reuse by humans and machines. And I'm not particularly interested in data from the context of this talk. I'm going to be talking about a little bit about research software and then more about machine learning models. So if you look at all of these principles, or a bunch of these principles, they often use this term metadata. And so it's worth just remembering that that's metadata and data. And if we're not talking about data, then there's a question about kind of what are we talking about. So the principles, again, at a high level, are intended to apply to all research objects, those that are used in research and those that are research outputs. Sorry, give me 1 second to clean something off my screen. Okay. And as I said, there's this metadata term that's used for metadata and data. And the FAIR principles, the FAIR data principles, as I often call them, are applied via dataset creators and repositories. And those 2 different sets of roles collectively are responsible for creating and annotating and indexing and preserving and sharing the data sets and their metadata. But if we think about non-data objects that we want to make fair, they can be stored as data generally, but they're not just data. And the ideas of making them findable, accessible, interoperable, and reusable certainly are good for a lot of different kinds of objects, but the details of how that's done actually depends on how those objects are created and used, how and where the objects are stored and shared, and how and where metadata is stored and indexed for those kinds of objects. And so there's work needed to define and then implement and then adopt principles for other kinds of objects that are not just data. The EASC task force, the Fair Practice Task Force of EASC in 2020 put out 6 recommendations for the implementation of fair practice, and recommendation 5 was to recognize that FAIR guidelines will require translation for other digital objects and that such efforts need to be supported. So again, I'm not making this up myself. There are others that believe also that the FAIR principles, the FAIR data principles by themselves are hard to apply to other things, and then work is needed. And so again, I'm going to talk about machine learning specifically. But before I do that, I want to just mention that there's other things that have also been looked at for non-data objects. So there's a group that's looked at how to make training materials fair, a group that's looked at how to make computational workflows fair, a group that Fdos and I are part of that's just finished developing a set of FAIR principles for research software. And there's work on making virtual research environments fair, and probably other things as well. So in the FAIR for Research software world that just finished, we worked under RDA, Force 11, and RISA, the Research Software Alliance. And we basically were looking at how to define and effectively apply FAIR principles to research software, and then how to achieve adoption of those principles. And so starting in, well, actually we started in late 2019, we became a group officially in March of 2020 under RDA. And then we did some initial work that led to a community consultation in early 2021, a bunch of other kind of iterations and reviews and rewriting. And the principles then were published as an RDA recommendation in late May. So we actually have now finished, and we just declared the group over quite recently. And this I just want to put up as a citation. If you're interested, you can go to this DOI. You can get to it through the RDA page, and then you can see what we've done. So as I said, the original FAIR principles claim to apply to scholarly digital research objects overall, but they really focus in detail when you get into the principles on metadata and data. And so groups like our group on FAIR for Research Software and a group that Carol Goebel led on FAIR Workflows, or maybe is leading, focused on how to translate and interpret these principles for research software and workflow. So we now have FAIR principles for data, we have FAIR principles for research software, we have FAIR principles for workflows. What about machine learning models? Are machine learning models data? You might say yes, you can think of them as a set of parameters and a set of options for a particular machine learning framework. You might say that they're software, right? Because a model is an executable object that takes input and provides output, and that sounds like software. They might be a combination of data and software and workflows in some sense, or they might be something else. And that's what we're really trying to figure out at this point is how do we treat machine learning models within the context of FAIR, given existing work on data, on software, and on workflows. As I also mentioned before, there's really large elements of FAIR for data that's dependent on archival repositories, things like Zenodo or other things that are in re3data.org. And these archival repositories hold the data, and also they hold metadata, and they provide search and access capabilities. When we were working on software, we realized that software is different because it's not typically shared through archival repositories, but instead it's shared through social coding platforms like GitHub or GitLab, or package management systems like PyPy or CRAN. And in GitHub, for example, there's no metadata that is stored anywhere. In the package management systems, there's some metadata, but it's not necessarily the metadata that's needed for all cases. So if we think about machine learning models, it's not really clear where they fit at this point. I don't think we have the experience yet. We could say that they're going to be searched and shared via the same repositories that data is used in, is stored in. They could be searched and shared via executable platforms. I could think of maybe a model as a service, for example. Or they could be searched and shared through something else. And there are a couple of things, the Deep Learning Hub and OpenML, that are examples of things that are not really repositories and they're not exactly executable platforms, but they're kind of a combination of those plus some other features. But they don't necessarily have the metadata that we need. And there's no way of searching across them right now. So the other question that we have is that models and training data are linked, as Rob mentioned. And so should they actually be shared together? If they're not, should the metadata in the model point to the metadata of the training data that was used to generate that model, for example? Or maybe the other way around, training data should point to different models that were generated using that training data. We don't know this yet. So we've been trying to look through these things, trying to understand what the issues are, what the questions are, what ideas we have for answers. And we started with a poster that was at RDA VP 16. I'm not sure that necessarily anybody saw this poster. I think in this first virtual plenary, I'm not sure the posters were very well understood. I think certainly things have gotten a lot better as we've learned how to deal with virtual systems, virtual events. We had a BoF at RDA VP 17, and that was much better attended, and we started building a community there. We gave a talk on this at the Fair Festival. We had an open community call with people that had expressed interest up to that point. I gave a conference talk. We had a BoF at VP 18. And in there, we talked about possibly forming a working group and maybe writing a white paper. And then we had a BoF at the supercomputing conference last fall. And so where we are now is that we've assembled a set of platforms, a set of communities, a set of projects, effectively stakeholders that have a key role to play within this domain. And we're trying to find out, are there more stakeholders that we should also bring in as we move forward, hopefully to an interest group. So we're thinking, again, of 3 different kinds of things at this point. Platforms, DL Hub, I mentioned OpenML. I also mentioned Keepoi is another kind of a repository of models that lets you execute those models. There's communities like the Pistoia Alliance that's looking in healthcare, Elixir that's looking in life sciences a little more broadly, and Claire, which is looking at AI research. Each of these communities is setting up kind of standards and ways of dealing with their own models, ways of searching models, finding models, things like that. And then there's projects. And so there's a project I work on that's FAIR for high energy physics. It's developing a FAIR framework to help high energy physicists understand how to best connect data and models and store them within a FAIR framework, within a FAIR sense. And there's an HPC FAIR project that's looking at particularly models and data that require HPC in order to run. There's also some interesting work in the geoscience area, in the earth science area, that we've also come across. But if you know of other things, it would be great if you can let me know, maybe through, well, however you'd like. You can get to me from the first slide, I think has my email address. So, so where we are then is, having assembled these potential groups of stakeholders, we're planning to write a interest group charter for this FAIR for machine learning interest group within the next couple of months, and then submit it to RDA, hopefully for approval. And the objectives in the interest group would be to talk about where FAIR should apply to machine learning, considering, again, other work that's going on in FAIR for other things, and trying to figure out what's missing for machine learning specifically. To define some cases potentially for new task forces or working groups in the FAIR for Research Software project. I think we were really very effective by breaking up the work that we needed to do into smaller working groups and then having them come together with answers that we could assemble. And ultimately what we want to do is to build a community of practice that is interested in both machine learning and how FAIR applies to machine learning. We are thinking about hopefully at some point this interest group or working groups that might spin off would create guidance documents and recommendations and good practices, maybe even things like checklists, definitions and crosswalks and standards and terminology to help define the field better, as well as potentially technical infrastructure specifications, so that if a machine learning model is on one platform and you're searching on a different platform, maybe we could do federated search across these different platforms that are developing, for example. So this is really, I think, where we are. We're hoping then that this group would be able to create a set of use cases to define what's needed for FAIR for machine learning, and that again may have a lot of overlap with existing FAIR principles, to make recommendations and guidance documents, technical specifications, as I mentioned, and then finally to think about actually producing and offering training once we do have these outcomes, because we do have RDA groups that are interested in this, as well as some of these external communities and networks. So I think that's about it. Yep. Sorry, one last piece. So we're going to try to finalize the charter. There's a link to it in the slides, and there's a link to the slides that I put in chat for those that were here, and in the notes document for those that came in after that message. The first 12 months of the interest group would be really focused on building the membership and defining what we need to do and making the connections to other RDA groups and other external communities and projects, and then figuring out like how to break up the work that we need to do and what those initial task forces or working groups would be. So thank you, and if you're interested, again, please send me a note, send Fdos a note if you know him. If you know of projects or other people that we should be reaching out to, please let us know that as well. Thanks very much.
Thank you, Dan. And it sounds like we have more than 2 people in the room now from the applause. So very good.
Yes, we do.
Great. Thanks, Dan. And if anyone has a question or two, please, I think we have time to do that. If anyone there in the audience or online has a question, then please feel free to ask them now.
Rob, we would love to meet the VIP with you.
Oh.
Hi.
Hi from Korea. Nice to see you. Thanks for sharing your dad. We know you're getting tired, but he's almost done with work.
Thanks. And apologies for the interruption. I actually had her bring me a glass of water, so if my throat gets dry, I can continue to talk. So then questions still. I see there is some activity in chat, but those look like
Jan has a question apparently. So Jan, you could moderate your and ask.
Thanks for the presentation, Danielle. It's a very interesting issue. Actually, we face the same issue. I come from computational neuroscience, where we used to share also models of neural networks and things like this. And that's actually a complex issue, right? Because machine learning is just more than code, and it's more than parameters and so on. So it's really interesting. Now I'm just wondering, and one thing that that is also appearing in other kind of data, how much metadata you get on machine learning algorithm, and is there any particular metadata schema that exists that actually describes fully or provides some, I would say, searchable content for machine learning?
Yeah, so I think there actually are a couple of different things going on. So there's work going on in ESIP, which is the Earth System Information Partners. There's a working group there that's looking at this issue, and they've come up with some guidance primarily for Earth scientists, and maybe that helps Jill with the question as well. The other piece is this Pistoia Alliance that I mentioned has been working on this for life sciences, but life sciences focused on really on medical care and medicine, as opposed to more theoretical life sciences. And they actually are trying to, I would say they're trying to represent industry and academia together, which is kind of interesting, and focusing on pre-competitive technologies and ideas. So they actually have a number of interesting relationships that they can bring together, which has been interesting. But again, I think one of the issues is this Earth Science group and this medicine and medical group really haven't talked yet, and so we have kind of different sets of guidance on metadata. We haven't done the work yet to try to think about how those fit together and what the overlaps are. I don't
Yeah,
know of
that's
other I don't know of other examples, but other people here perhaps might, and that would be interesting to know as well.
Yeah, I was just curious about the amount of specific metadata for describing machine learning algorithms were out there. So at least there's some, so which is good. We're facing the same thing with ontologies and controlled vocabularies, where you do have several models to describe them, and now there is an attempt to try to federate them so that there is a, I would say, harmonized metadata. And there's some work we did in FAIR, trying to come up with a minimum metadata for FAIR semantic artifacts that includes ontologies, because FAIR are also quite imprecise. They just say that you need to provide rich metadata, but rich, what does it mean exactly? So, yeah.
Yeah, rich is one of those terms that can be interpreted many ways.
Yes.
I do want to say the other thing. Oh, go ahead.
Oh, sorry. I was just going to, I'll put in the link to the ESIP machine learning group in the chat if anybody's interested in following up on that. Hopefully that's also helpful to Jill. And then I was just going to say to Jan that we are focused on machine learning models, and we've done that intentionally because, in my opinion, at least, when people would use the term model, they mean they can mean incredibly different things from ODAs to algorithms to code to a variety of things. And so we're trying to focus on something where we think there's enough, I don't know, potentially enough convergence that we can do something useful.
And let me say the other piece of the puzzle that I've found in just kind of taking some state-of-the-art algorithms and trying to build models from them is that the hardware environment needs a description, right? So not only whether it's a CPU, GPU, but the versions of the CUDA compilers is one that I've fought with quite a bit in just, as I said, grabbing some image processing software and trying to get there. So I think there's another piece there, and that's the not only the software environment that you're going to land on, but the hardware environment that you need for at least creating the models. So, okay, next we have Christine Kirkpatrick, who is going to talk to us a little bit about the fair digital object approach and fairness in general. So we have a place to compare AI readiness with. So Christine, take it away whenever you would like.
Okay, and thanks, and hello again to everyone here in Seoul, and hello to the friends I see online. Maybe next year we'll all be together in person. It'd be great. But so I'm representing today the Fair Digital Object Forum. If you're like, wait, I thought you were part of CoData. I thought you were part of GoFair. I thought you were part of RDA. Yes. but with this hat on today, I want to give you a brief overview of these activities. Let's see if I can figure out the clicker. It's on. Yeah, I'm trying to. Well, and Phil, maybe you could just advance to the next slide. Oh, one back. Okay. So why do we need this new thing called fair digital objects? Okay. Thank you. There we go. So two key reasons. You don't have access to all the data to include all of the meaning about it. And this is especially true of massive amounts of data like you get from NASA, say, or other instruments. And maybe you want to add some context to it, but you don't necessarily own the data. This gives you a way to provide a wrapper around that data to give some commentary, if you will. It's also a wonderful way to package the data with the metadata without having to embed it, right? So schema.org, for example, yeah, that's requiring that you have some access to, well, unless you're only linking to talk about the data repository, otherwise you're trying to embed some things in there. So it gives you this layering approach. I think the promise of FDOs is that in the future, it's possible that we won't need so many copies of data. We can leave the data where it is and maybe provide different wrappers, which would be very lightweight because it's only text, right? And then I think what I'm really excited about is this could potentially be an approach for globally identifying misinformation and saying either this reading was junk, or this, this is a video that is, been completely manufactured, etc. And so hopefully this will also allow us to enact some of the things that we've been talking about with data federation, but in practice are very hard to do. Okay, so defining FDOs is a bit like everyone's touching a piece of the elephant and trying to describe what the elephant is, but there's an analogy that Baron Mons likes to give about a file box. Peter Wittenberg says about a Rubik's Cube. For me, the thing that makes the most sense, because I've done a lot of collaboration with social scientists who use Twitter data, and apologies if you haven't worked with Twitter data much, but you probably can imagine, you've tweeted. A tweet has an identifier for the person who tweeted. The message has an identifier. You also have some metadata associated with it, sometimes location, perhaps an image that's been tagged. And there's a global identifier that wraps all of this information together. And I would say a tweet is probably the closest thing we have right now to a fair digital object, although the DISCO project out of the Netherlands with Naturalis is another example of fair digital objects in action, where they have physical objects and then a digital record of that physical object that's packaged in this way. Sorry, I'm trying to figure out the clicker here. Okay. Again, this just gives you another graphic for thinking about this. So one of the key ideas is that there are unique identifiers for all these pieces, as well as a unique identifier for the thing that talks about it all, right? That one object. And so instead of embedding the meaning, we're wrapping it in, like if you know the movie Shrek, that was something that my kids watched when they were growing up, and the donkey says, Shrek says he's like an onion, the donkey says maybe more like a parfait. That kind of idea, right? A present. Apologies with I don't usually use, I've been at my computer doing Zoom for the last 2 or 3 years. Okay, so a short history of FDOs. This is actually, even though FDO embeds another acronym FAIR in the title, there was such a thing called the digital object, and there are many papers if you go back and read, starting in the late 1990s. And that's where some of the thinking comes, but it's been reinvigorated. I would also point you to this 2006 paper if you want to kind of see where this idea came structurally. Over the last 5 or 6 years, we've had projects such as one that Rob Quick has worked on, Larry Lanham, if you know them, things that have handle registries that can give out a lot of these unique identifiers. And then this thing called DOIP, DOIP. The Fair Digital Object Forum was the idea was birthed at this Getty Paris meeting, and the FDO Forum was formed in January of 2021. Okay, so a little bit more about that. It's a steering committee with some co-chairs that drive it, and we have Tina Liu in the upper corner here as a project manager. So if you get involved in it all, Tina's really the one to talk to. We have representatives from around the world, but we're always looking for people who would like to engage and help steer this. Here's a bit more about our steering committee. Okay, so how many of you heard of the Data Together? So familiar, I know Hillary knows all about this. So this really represents really the 4 big research data consortia and how they fit together. And people ask, is the FDO Forum a new thing? Gosh, I hope not. We're not trying to create a whole new thing. We're hoping that it's kind of this, in the bottom right here, this overlapping thing that is a concept that's worked into all these data consortia, and that over time, any organization is happening through these data consortia. It's okay to quote me, but we might have some disagreement about that in our organization, but I think that's where it's headed. Okay, so there are several dimensions of FDOs that need to be worked out, probably more on the social than the technical side, or rather they're harder on the social side. On the social side, I think FDOs right now are maybe easier to understand if you're an academic, someone who would come to International Data Week. So we have to figure out how to explain this to policymakers. Now, that said, there's a huge activity in Germany right now where they're looking to FDOs as a way to implement some of their new data regulations. And then industry as well. So they grapple with, how does this fit into everything else that we've been trying to do? Is it really worth the investment? And so these will be some of the things that the Fair Digital Object Forum or the interest groups that I'll tell you about at the end will be working through. And then the last thing is, so if we say that FDOs have promised to help with globally identifying misinformation, well, who's tagging that? And how can people consuming data recognize when it's been tagged that way? How do they know which thing to trust? There's so much to be worked out there. On the technical side, and I'll talk a bit about our working groups, but we really do need to coalesce on an architecture and a framework. We have a few different things that are out there competing with some overlap, but I think what we need are several proof of concept projects to really show how these work and to work out the kinks and to figure out, okay, how will people actually do this? If you remember the early web, we had all kinds of crazy technologies and things that we just discarded. I mean, do you remember Flash? You know, we need to make sure that we implement something that's, you know, embodies the FAIR principles, plus is open. And so I think with the people involved that could happen, but it could also be that this takes off in industry and we get some implementations that are a bit proprietary. I get pretty excited when I try and think ahead about the new tools that we need to develop. I'm very excited to think what the next browsers will look like that understand how to do things not just with text, but also data, and that can recommend what things that you need to pull out the tags or the metadata from the digital objects that should be highlighted, as well as what we will use to produce this information. It needs to be much easier. It can't just be using a text editor and knowing, you know, archaic vocabularies and ontologies. Okay, so these are the 5 working groups. There was a previous working group that launched, achieved its work, wrote a paper, and it's now closed. The newest one is this FDO FIP, which has some overlap with GoFair, which is the FAIR implementation profiles. I would say the FDO TSIG is the most active group at the moment, and if you're interested in how this will work technically, that's one to follow. We have twice a year community information meeting. So we just finished our second one in March. And this is where the groups report out on what they're doing. Also on our website here at the bottom, fairdo.org, we have several papers and we publish them as they're, we post them as they go through the process, and we often have comment periods. So please let us know if you have any feedback. And if you're particularly interested in contributing to one of these groups, contact one of the co-chairs of the steering committee or the chair of the group directly. Okay, so we have a few things underway. One of them is the contest called Name That Space. So this is the idea that there's a next version of the internet coming that will be based around FAIR digital objects, or will be much more data-driven rather than text-driven. And so just as there's the term the metaverse, right, that helps describe something concrete, we need something that describes concretely what the next version of the data-driven internet will be like. If nothing else, you might go to that site and read through some of the suggestions, because there's some pretty funny ones. But if you are great at naming things, please go there and give us your thoughts. My favorite one right now it kind of looks like weirdo. It's like, I don't know about you. I don't think that's going to be it. Apologies if anyone on the call is the one who thought it should be called weirdo. Okay. I know you probably have too many things to do and too many things to read and too many links, but I promise you, if you want to hear more about this and just open up your way of thinking on what the next version of the internet could look like, this was one of the best talks I'd been to in a long time and really sticks out, even if it's just the first hour or even just the talk by Professor Florides on this high level view of what the future data space looks like. I think, to give you a few highlights, he really talked about how much more important governance and policy will be with data in the next 10 years, more so than the technical challenges. So please look for this. And then there's also a paper that will be published soon that highlights some of the points in here. FDO events. So today and yesterday, FDOs were featured. Please think about coming to Leiden at the end of October. The last 2.5 days of the unfortunately named Hot Zone Week will be all about fair digital objects, and it will conclude with a declaration that will be signed by some important people who are committing to FDOs. Oh, and I did forget to say, we have a call for abstracts. If you have thoughts on any aspects, from the social aspects to the philosophy of fair digital objects to the technical implementation, please, please, please consider putting something together. And this is a very new space, so it's okay if it seems out of left field. We would love to read it. Okay, so the interest group for fair digital objects is here at RDA. It's called the Fair Digital Object Fabric IG. It was previously the Fabric, Data Fabric Interest Group. I'm still tripping over the name. It's chaired by Rainer Stutzka, Rob Quick, who are both also on the FDO forum. And so this is meets monthly, and it's an open meeting, and it's a great place to kick around the latest that's going on. I also wanted to highlight Maggie Hellstrom, who's working through this interest group on designing training materials and events. So basically FDOs for all of us on the ground working, trying to implement things. How do we spread that? And it works hand in hand with the evolution of FDOs, because in trying to explain how to train someone on something, you find lots of things that need to be streamlined. So please, if at all interested, contact Maggie Hellstrom. Okay, and that's the end of my talk. I'm happy to take any questions. Please consider coming to Leiden. We also do have virtual attendance available online, so see you either way. Okay, I think that's it.
Thanks, Christine, sorry. Questions, we can field one, I think, and then we need to move on. And Dan has his hand up, so and I can't see if anybody in the audience actually has their hand up. So we'll do one for Dan, and then if anybody in the audience has a hand up, we can answer a question there too. Go ahead, Dan.
Yeah, great. Thanks, Rob and Christine. I'm just going to kind of gently poke at the fact that that after the FAIR principles came out, we now have FAIR digital objects, but they still are focused on data, and they don't actually seem to discuss any other kind of objects. So so I feel like this is kind of like I don't know, whitewashing of the name in some sense, that I hope we can expand and make FAIR digital objects actually FAIR digital objects and not just FAIR data. But the question that I was going to ask is, what's the relationship between FDOs and RO crates?
You're trying to get me in trouble, Dan.
Well, because it seems like that's like a previous version of
Sure.
objects in some sense.
So I wish that we could have Carol Goebel here and Peter Wittenberg and Luis Bonino. That would kind of give us some three different points of view on this topic. I think RO crate is a concept of wrapping meaning and layering meaning. So in that way, it's similar. I would say that RO crate, as I understand it, it's been very focused on workflows, and is not trying to provide a new architecture for the next internet. It's trying to give you a way to wrap up digital objects so that you can explain them, or sorry, you can exchange them with colleagues. But I have, complete respect for Carol Goebel and her colleagues working on this. We've actually had Carol come and give webinars on this topic, as well as how RO Crate fits in with workflows. And so I'm familiar with it. I wouldn't say I'm the best one to give something that would end up being a very subjective view of the differences. But can you just use RO Crate and then you have fair digital objects and we can build the next version of the internet? No, I don't even think Carol would say that. But could FDOs perhaps borrow more from RO Crate? I think yes, perhaps that's the case. Hopefully
Okay, I think focusing on
diplomatic.
so focusing on the use case, I think is helpful rather than focusing on the technology. So thank you.
And Dan, thank you for reminding us that we need to talk about more than data. I think that it's difficult because it's so even though it's an old concept, it's kind of a new way of thinking about it. People aren't implementing things this way. And so we start with the thing that we all work with. But you're absolutely right. In fact, for my own work in machine learning, and as Rob was talking about, it's so important to document the system information, especially if you're trying to document things for reproducibility. It is really lacking the models for how you would package this all together, and it hurts my head trying to figure out the answer to it, but we need to.
If I may jump in, use RO Crate to package everything, because that's the purpose of RO Crate. It's been developed as a research object initially to actually package all the data and necessary information you need to actually reproduce things. So that would be the difference. Is like RO Crate should be a collection of FDOs, because you point to the data, to the software. And so there are also discussions in the FDO forum about typing and what are the types of fair digital object we can encounter. So it's not restricted to data, right? But still, I mean, the global model remains the same, or should remain the same, whether you exchange data or code or whatever. You need metadata, PID, and this sort of structure. I hope that also helps answering the question.
Thanks, John. And Christine, are there any questions in the room there? Because it would be good to take something from one of the live participants.
No, not at the moment, but everyone's here and listening and engaged, and so don't.
Okay, well, very good.
Thank you.
So,
I mean, I don't think anyone feels neglected, but I will keep watching for questions.
So two real quick comments from me before I start. Christine, you said that the social aspects were harder. I agree that they are harder, but I don't want people to think that the technical aspects are easy by any means. The technical aspects still need a lot of attention and still need a lot of work. And while the base services are in place, having those base services operate as a federated set of services for a wider use is still a long ways off. And still will take a lot of work. The other one is I agree, as many people did with Dan, that we should be talking about more than data, and getting in that technical group and the basic infrastructure group, and making sure that they are making they're considering things beyond data is important at this stage, or they might end up being forced in afterwards in the wrong way. So, okay, I'm going to share my screen again. And see if I can get my slides up. That is the wrong. There we go. And view. Okay, and you should be seeing my slides once again. And so I'm going to make this somewhat brief so we have time for discussion, but I want to again say the motivation behind this was me being curious after having the conversations in Paris, which Christine mentioned, and people equating FAIR, the data sharing principles, with being fully AI ready. And this, to me, I think that my initial thought was that FAIR gets us closer to being fully AI ready, but I wasn't sure that that was a legitimate comparison, at least to refer to them as basically the same thing. So a quick word about open science. I've had open science in my title since 2002, so 20 years now. It was the first time I took a position that had open science in the title. I've been working on this for a long time, including some funded projects by the NSF that created a test bed for FAIR digital objects. So my view on this fairness is really tinted towards the FAIR digital objects. And this sometimes leaves out things like linked data and other processes that may lead to the same final goal. We talked about the FAIR principles, but just to reiterate that what the FAIR principles are, they were defined in a 2016 paper, and really try to achieve that open science with data and, as we said, possibly other things also. And it provides those technical and social guideposts to publishing data in research science environments. It's also getting recognition in I know, Europe, with a lot of the EOSC proposals, and then recently in the US by both the NIH and NSF have had specific solicitations regarding that have had FAIR basically in the title of the solicitation. The most recent one, the NSF's FAIR-OS, was looking for research collaboration networks. And I think this is an important step for FAIR to really make it into the funding agency's top line of attempting to find projects that are worthwhile to fund. I won't go over the FAIR principles in detail, but here they are. As I said, some of them are more technically minded, some of them are more socially applicable. So the first thing I did when I decided to compare FAIR with so the two FAIR terms is to look up what AI readiness means. And I found this definition from the Department of Defense, and that's taking steps to collect data around relevant systems, equipment, and procedures, and storing and curating that data in ways that it makes it easily accessible to others for future AI applications. And by future AI applications, I take that to be reuse of the data, the equipment, the procedures, the systems. So I will propose that there's no such thing as fully AI ready, and that's for many reasons. While some data sets may be particularly mirrored to an AI algorithm or model, those are usually paired up pretty easily. The AI application space is just way too diverse for a fully AI ready term to have any meaning, at least on a large scale or a general scale. Now, I think that we could provide a degree of AI readiness based on some of the top algorithms that are used in various different subdomains, and possibly a future profile standardization may allow the fully term to be reintroduced. But now I think this is basically should be a comparison of FAIR and AIR, or AI readiness, versus the term fully AI ready. So existing in the RDA, there are several different outputs, including those things that are being talked about in the FAIR for machine learning. There's a recommendation for a base PID kernel information. This is the base profile that would allow data to be homogeneous and would also allow, Christine mentioned the digital object interface protocol, DOIP, to do high-level operations on digital objects, whether those digital objects are data or something else. It was defined by the PID kernel information working group. It's not definitive, but I think it's a good starting point for what is the core of fairness. and it's used as a baseline. I mean, this could be used as a baseline as a starting of what are the initial continual fair metadata objects that need to be available. And then this can be extended with additional profile information. And along with that, you need to really determine what additional metadata is common to many AI applications. And this cannot be fully complete based on the diversity of those applications. However, if you look at some of the state-of-the-art and the state-of-the-art as defined in many ways, so I use that term, but really what I'm saying is things that rank well on given given tasks or given benchmark data sets to produce a certain amount of accuracy. And more simply, what metadata needs to be fed to an application to either create that model or complete an analysis? Or even better way to put that would be, what does it take for an automated process to find, access, retrieve, and analyze a targeted data set? And this includes the data, but also the other aspects of that, whether it's the algorithm to build a model or the model to analyze the data. So a proposed method, and this again is me thinking about this, is to survey these state of the applications. And where I go to is usually to determine, what this is and what are the kind of current repository of applications is a site called Papers with Code that really does kind of the accuracy analysis and publishes which ones are the most accurate for certain types of subdomains of AI, and determine what is needed to successfully build the model and or do the analysis. Compare that metadata input with the PID kernel information profile and create a profile or an extended profile. So it might be something like PID kernel information plus AI, though I think that will even have to be broken down to subdomains, because what you need for an audio analysis is quite different from what you need for an image analysis, is quite different from what you need for a natural language processing analysis. And then, of course, then there has to be this fabric that allows you to register both the data and metadata based on the FAIR profiles. Initially, I considered these four subdomains: vision, audio, natural language processing, and medical, though medical seems to not quite fit in that list, as many of the things that medical do are other applications of imaging or computer vision, or for machine language or natural language processing to browse papers and determine likeness within large amounts of published literature. And I think others can be added later, but at least the top three there, I think, are pretty important current applications that are actively used and are kind of this base of what's happening. And I do think there are places in medical that don't fall into the top three, such as drug discovery, some diagnosis, though segmentation is very much also a computer vision, just targeted at medical medical implementations. So I did do a brief survey of common AI benchmarking data sets. I identified 48 of these common benchmarking data sets, and these are ones that you can find basically online and try to at least get some compare with other algorithms what the accuracy may be. There were I just noticed the pattern here. It goes down by 2 each one, but 15 NLP applications, 13 image analysis, 11 audio analysis, 9 medical implementations. And I tried to find what I thought was the very basic metadata for each of these in a human readable form, and that meant that it was either on the home page where I found the data set or in the README file that was delivered with the data set. And those fields were the format of the data, what sort of file format it may have, a license, so it could be, so I could determine whether it would be reused or would be worth using somewhere else, and the author, so there could be some attribution. The results of that was it was nearly impossible to find even the link to some data sets identified without human interaction. So I found no way that was common amongst any of the benchmarking data sets that I could have found, even these 4 very basic pieces of information, and spent quite a bit of time actually looking through both web pages and README files. And even at that point, only a little less than half of those 3 fields was available in either the README or in the place it was put. So real quickly, a path forward. I think that partnering with the Fair for ML group is probably the direct, or is the best place for people who are interested in this activity to go towards, as most of the things that I looked at that are active, widely used, wide applications at this point fall into the AI subdomain of machine learning. Then we can produce some recommendation profiles for those AI applications, and in the subdomains listed, though, as I said, it can grow again later, and look for additional ways to provide fair AI solutions. And my kind of last minute, 10 minutes before we went live, thought was, if things went, a pie in the sky kind of goal would lead to an AI matchmaking science gateway or a virtual research environment. That would be one that a user could show up with a PID, and they could matchmake the applications with the data set, with the runtime environments and the compute resources. But that would take proper descriptions of the data sets and the metadata for that data set, the software dependencies, the hardware environment needed, the applications requirements for metadata input. So it would take quite a bit, but I think that that this at least should be the pie in the sky goal, is that with a set of PIDs, you could know nothing about or completely abstract what's behind the scenes, and give a analysis result to an end user. And I called this the general AI notebook gain, and I use notebook there more for the acronym than this would be a notebook, though I do think this could be implemented within a notebook style environment. So that's the end of my talk. I did have 2 slides here from Eric Schultz, who wanted to also make sure that we were at least mentioning the FAIR data visiting. And data visiting is a method to keep a data in place and ship the algorithm to the location of the data for the run, so the data can still have all of the proper security methods behind it, and allow a visitor to analyze the data, though not take the data or copy the data or remove the data from its home environment. And this is something that there are several links here, and again, I'll make these slides available at the end. He also asked me to talk about the metadata for machines workshops, and this is a group within the Go Fair Foundation that was really has been quite active over the last couple of years in looking at what metadata is necessary for machines to use to do automated workflows. There have been several workshops, as you can see here, and I will stop at that, as I don't know a whole lot about it, but I would encourage people who are interested in either the data visiting or the metadata for machines workshops to contact Eric Schultz, who was not, I know it's very, very late where he is. I won't cover my references, and we'll stop the share and take any questions you may have. And it looks like we have about 15 minutes or maybe closer to 20 minutes to answer questions and have discussion. So I'm looking at the chat now, but if anyone has questions, please feel free to chime in if you're online or step up to the microphone if you're in the room.
I think all quiet here, Rob.
Okay. So if there are no direct questions, then I think we can start the discussion. And as I said, I think we have about 15 minutes. Christine, you said they want to wrap up their on-site at 5 till.
I think that's nice. Then people can get to the next thing on time, unless you want to go right to the last minute. You don't want to be any minute taken away from this topic. We can go right up to the hour if you want. Oh, there's a break. Well, we have we have a little flexibility, but I know, Rob, you have a hard stop. So I think people are taking it in, feeling satiated. I think it's okay, however the conversation winds down.
So I do want to say that we've been somewhat fair digital object focused in many of these talks, and I know, Jan, you had some questions about linked data and the fitting linked data into the equation. Do you want to talk a little bit more about that to start the conversation?
Sure. So I'm actually also involved in the Fdos Digital Object Forum, and I'm co-leading the Fdos semantics, which is, the idea is to actually have an implementation as linked data of the Fdos Digital Object, because these are two slightly different approaches, although the idea is to make them converge. And one of the reasons for that is because if you look at the FAIR principles themselves, first you will find out that principle I2 says that you need to document data and metadata with vocabularies that are themselves fair. So that means that for the implementation of FAIR, semantic artifacts like ontologies or controlled vocabularies plays a huge role, and it can only play it if they are in the linked data context, right? I mean, their full power would be there, which means, in a sense, that, of course, it's not said in the principles because it wants to be technological. Sorry, it's really late. Technically agnostic, but still, one way of implementing it is to actually to use this linked data. But then that raises the question: how do you link data with AI? Would that help actually if you have your data sets, for instance, that you would like to use for training, that are all represented in a graph that you can just traverse the graph and find out the data you want for training your machine learning algorithm? And how would that be made? Can all the machine learning algorithm actually work on that kind of structure? And my final question is, like, because that's been the topic of my work in the RDA and in another European project called FAIR, if we have all the ontologies that exist that are made fair, can it help AI actually? So there are a few things and pointers. So maybe if you have some thinking that you would like to share, or if you have any information on that, how to link AI and actually link data, and if there are already implementation of that, for instance.
Sorry, I was muted there and talking. I would be curious as to what the FAIR for Workflows group published, because I think a lot of the at least for the workflows, a graph seems very attractive, particularly acyclic graph representation seems to work well in workflow type environments. So I'd be curious as to what their recommendations were or will be. I'm not sure if that group is still active. But yeah, I think in general, a description of with a graphing description, and maybe it's because I come from a HPC, HTC background seems like a likely, or seems to be very beneficial. So go ahead, Dan.
Yeah, Dan.
Yeah, I was just thinking that I think the idea of representing the workflow as a DAG, directed acyclic graph, is a very useful concept at some level. Well, I personally don't think it's the right level to be thinking about the workflow, to be theorizing about the workflow. It's a nice level to be storing the workflow for reproducibility and for reuse. But by the time you get to the DAG, you've lost a lot of the kind of the knowledge that was there to begin with. So this is kind of a personal, I guess, opinion. I'm not really speaking for the workflows group, which I've only been watching and haven't really been part of. But I do think that there's questions that will come up. They come up there and will come up, I think, here as well in terms of which abstractions make sense at which levels, and how do you translate to and from them from other levels, and what do you lose when you make a translation.
Thank you, Dan. Anyone else wants to say something on
I
that?
think we have a comment from the audience, but you'll need to come to the podium
Yep.
for the. I'll try. Yes.
Elaborate on that and maybe propose something different?
Sure. So our colleague here in the audience, Renee, asks, can you expand on that and maybe you said provide an example or
What would you suggest?
expand? What
I
would
understand what he says, and it's really interesting.
what you say is interesting, but how would you suggest doing that? And was
So
this
how would
directed to Jan or Dan? To Dan. Okay, Dan, you're on the hot seat. Tell us, what would you do?
So I don't think that I know what the right answer is here, but I guess the example that I'm thinking of is that there's work that I did, I don't know, 20 years ago. I was part of a team that was working on an astronomical imaging mosaic tool called Montage that built mosaics. And we were using Pegasus at the time as the workflow engine. And so in order to do that, we had to write this, basically this Pegasus DAX file. It was a directed acyclic graph. And in order to write that file, we had to write a program that took the knowledge that we had of the workflow and then translated it into that format. And then the workflow tool worked with that, and that was the thing that got preserved. And I think that, again, that made sense in terms of optimizing the workflow, in terms of making it reproducible, in terms of storing it. But it was the program that actually generated that DAG that was the very compact way of expressing the knowledge about what the work actually was. Right, it's kind of like taking an algorithm versus assembly code. Right, the algorithm is much more understandable. The assembly code is the thing that actually gets run in the end. So right, you go from one level of knowledge to a level where some of the knowledge is lost, but you get other benefits from that. And so I don't really have a solution here. I'm just again theorizing that pattern is going to show up in some of the work that we're talking about here. That there will be levels that are very compact and very easy to express, and then we expand them to make and translate to make the data easier to work with by tools, but we lose something along the way. And so which levels we choose to preserve things at, I think, needs to take that into account, that loss as well as that expansion or compaction.
Okay, so thanks, Dan. Any other comments or questions in the audience here? Okay. Oh, looks like Megan has a question.
Hello. No, I guess it's more of a comment, but yeah, Alan raises a really good point that we're trying to sell the value.
We're not hearing you, Megan. I think maybe a different microphone's
Yes.
picking. There we go.
Okay, wait.
That's better.
Oh, can you hear me?
A bit better.
Much better now.
Okay, I'm speaking into the computer microphone now. I think if Jan makes a really good point, if we're trying, I'm in agriculture and soils, and we're trying to sell the value of semantic artifact use to on-ground researchers, and AI models, machine learning is really coming up as, it's almost a bit of a buzzword in that field sometimes, but I think that's where we can help realise a lot of the potential of you know, control vocabularies, ontologies. So if we can bridge this gap, I guess it's more of a comment. I'm not, I've just been listening on with interest. I think it's a really interesting area.
That was the purpose of my question, actually, because I have no clue. The only thing that I found out at some point when I was looking at machine learning in AI is that Google came up with a machine learning algorithm that works on graphs, but I don't know how. To be honest, I didn't read the paper, and I think there are more algorithms like this that are emerging. But then the question is indeed, how do you connect things, right? Because if in FAIR you start documenting your data, your algorithm, whatever, and to put them into Fdos, at some point you need to have the machine that needs to be able to work with the semantics, and we want definitively to have smart software that is going to search and retrieve the right data for us. So that requires some machine learning as well. So the question is, how do you make all these things stick basically together?
Yeah, if someone has a nice answer and a good paper, then let me know. Be interested in reading. Thank you.
That could be a topic of the after the BoF.
So Jan, you don't see in the FAIR digital object the typing and it maybe even typing of relationships as being able to link this, because in the digital object, it's much like object-oriented program, right? Everything becomes a digital object, including things like relationships between two other digital objects. Do you see, or could you think that possibly within the digital object environment, that this graphs can be created by making the relationships themselves objects? So just a thought. I won't ask for an answer here tonight. I know that's
a very good question.
I've thought about this a lot myself. And how do you define the relationships between two digital objects? And that's the closest answer I can get to saying that, you know, a digital object environment itself can be used by itself without necessarily leveraging other technologies, and that linking being done by defining relationships as digital objects. And I'm not sold on that. I'm just, it's the one solution I've thought is a possibility.
I think there are different ways of doing that, and I think what you're just saying is perfectly fine. I mean, if you think about it technically, we were discussing, for instance, an ontology. It should be a fair digital object as well, and the concept within this ontology should be a fair digital object as well, because it's an entity that you will reuse. So in that landscape, that means that if you start thinking about the concept, you start thinking about the relations between the concepts. Therefore, they will become fair digital objects as well. Now, the hard limit is always difficult to set, because how far you go in terms of granularity in defining digital objects, right? Mm-hmm. So that's the whole question. The same thing that we discussed in typing, right? If you start typing fair digital object, basically what you're creating is an ontology of fair digital objects.
Yeah.
And so basically you can categorize and call them types, or you can call them concepts or global things. You can put them into an OWL ontology, and every object that would be of that type will become an instance. So there are many ways of seeing the thing. So the question is, how then, if there are these many ways, how do we make sure that they all work harmoniously, right? Because the linked data allow you to work on web-based with the content negotiation to retrieve a lot of things, and works perfectly with graph. Some other approaches may not work that easily, because well, you lost some of the power of the linked data. But yeah, that's the issue we need to figure out, right? Is the fair digital object.
Yes.
And for that, I do believe that we need use cases, and we need to start, well, not implementing, but prototyping. That's what we're trying to do in the FDO SEM group, that we're trying to have basic use cases and start thinking about the concept of FDO itself, trying to define it as a linked data object and so on and so forth. And that helps actually identifying issues and things like that. I see Jill raised her hand.
Yeah,
So Jill,
I want to get to Jill before we end the hour. Jill, thanks for reminding me that just regression models should also be considered in here, because I don't want to skip over the base case of regression modeling. So you have a question.
Yeah, I just, it's sort of a comment and maybe a bit of a question. You know, to me, I think some of the best machine learning or the best models are expert informed ones, where there's, you know, a bit of a collaboration between the expert in terms of what the inputs and things are, and then the machine, and then the algorithms or the models. So, you know, how can you even think about including that expert knowledge into some of that metadata, or is that something that's even possible or useful?
Yeah, so I think that FAIR really touches on that. If you look at the FAIR principles, I think being FAIR vocabularies and the richly described metadata, and there's another item in the reusable that's something along the lines, and I'm paraphrasing here, that data is in a common vocabulary of the discipline being used. I'm trying to pull up the FAIR.
It should use community-specific metadata.
Yeah, there you go.
That's what you. There's another one on metadata that is connected to richly, that is in reuse, which is metadata are richly described with a plurality of accurate and relevant attributes. You understood it the way you want.
Yeah, exactly. And Rob, I had a comment, but if Dan wants to go first, he's flowing in what Jill and Jan were talking about, that's fine.
Yeah, I actually had a comment on the earlier one as well as on this. So the one I was going to say first is that I think it's interesting to think about how the relationships between DOIs are expressed now, and how that system works, and to think about like what the problems are with that we need something better for, and hopefully to learn from that as we're building something new. I guess the thing I was going to say with Jill's comment question is I kind of disagree with Rob, I think, a little bit, and think that that FAIR, part of the power of FAIR is that it's pretty specific, and the more we try to expand it, the fuzzier and harder to apply it gets. And so I think like FAIR by itself, I don't think is tremendously defining in terms of what metadata there are, or how you would express experts or things like that. And that's kind of where I think where community standards come in, is on top of FAIR, how do we actually customize these relatively generic principles to be what a community wants to do and agrees on. But I don't think that you can necessarily embed that within the principles themselves.
Thanks, Dan. And Christine, I think we have just a few minutes left.
Yeah, I think I just had a meta comment. I mean, I thank you for inviting me to speak, and I think this topic is very interesting. We need to continue the conversation, but I think we, while going into technical details and brainstorming, we also need to keep it simple and light. I can't think of the name of the movie, but there was that one where the aliens came down and were taking over, but if you played country music, their heads would explode. And I kind of feel like if we have an interest group that's about graph databases, AI, and machine learning, and then linked data, you're going to have a lot of exploding heads in any room that's presented in. It's just too much. And so we have to make sure that we're dreaming of a place we can go together that is simple. I mean, I would guess most people aren't doing machine learning every day. It's hard. a lot of cuss words come out as you're trying to get the data to work, and then why aren't, especially with cloud, trying to figure out cloud computing. But I can on my phone find a picture of my dad. I can have it search for, if I've tagged my dad once, it will find all the pictures of my dad. I can put something on Instagram for Father's Day. This is understandable. How do we, even in our own community, bring people in and not scare them off? Because linked data hasn't had a big uptake, at least in the US and other places. It's hard for many researchers. Graph databases are about 30 years behind where we need them for the scale at which we would use them, but they're not good enough to use at the scale we need them. So anyway, it's good, we should brainstorm and talk about these things, but then we need to land back on Earth again and think, what's the next step forward?
Yeah, so Christine, I think this is exactly what got me thinking along the lines of that what I said was gain, was basically that someone could come without knowing a whole lot of the details behind, with a few PIDs or just names of the algorithm, the data set, and that they want to use, plug this in and get some sort of results that they could then use however they might like. So I think simplifying this beyond what it takes now. I consider myself relatively savvy, and it took me days to figure out how to get several of the what are called state-of-the-art algorithms to even execute
Totally.
to the point that I got a model. So I think that you're absolutely correct there, that we have to, the long-term goal has to be simplicity for the researcher who wants to leverage the power of machine learning and AI, but doesn't want to have to, spend days on end trying to get that to function at even the base level.
Totally agree.
Okay. So any last comments before we go? I see we're a minute past the hour here.
We do have a question. Would you mind coming to the podium? So one last quick question here from Seoul.
Very good.
Hi, I'm Young Im Jung from KIST, and it's very good to hear the good topics. And I operated a session titled Data Publishing in Open Science Era yesterday. And while I'm listening to this session, I was thinking that the two topics quite good for connecting each other. The outcomes and the outputs of data publishing, it can be connected to machine learning and AI data as well. So it is quite. But at the moment I do not have any concrete idea for that. But it is good for us to think about how to use or how to link the two topics together.
Yeah, I agree that there's a lot of ongoing work that should be leveraged closely, both in moving forward in the FAIR realm and in the FDO realm. So I'm in total agreement with you. Linking together and leveraging work is going to be necessary moving forward, so we don't start diverging and having different outcomes coming from different groups and nobody gathering onto what may be the easiest, best path forward. So with that, I want to thank Dan and Christine for their presentations. Thank Jan for helping out with the discussion. Thanks all the attendees there in Seoul and online, especially those who have stayed up very, very late to be a part of this discussion. And I look forward to reviewing both the notes and listening to this again and kind of taking some notes as to from the conversation for myself.
And Rob, thank you for the bravery and interest of putting something like this together, and good night to your daughter.
Yeah, thanks.